What I want to talk about now is SQL plan management. Now, I hope you were all with us a couple of weeks ago on our first session, because in our first session, Dave and I presented two fantastic features, which the general thrust of which was that if you let us upgrade your database, we would configure a couple of features, specifically the result cache and some optimized enhancements for parallel processing. We would enable those features, and like magic, your database will run fantastically compared to the way it ran before. Now, the question I was expecting to get from one of you but didn't was someone saying something on the lines of, "Hey guys, the last time I upgraded my database, the results were disastrous. How can you guarantee it ain't going to be disastrous again?" Well, I took a gamble. None of you asked me that, so I'm going to ask the question myself. So, how can we guarantee that after upgrade things will actually get better, or more importantly, won't get worse? Because this is a major problem with the Oracle environment, and always has been. How do you ensure stability? And that's where SQL plan management really comes into its own. The issues of change control. Oracle databases have always been plagued with problems of wildly erratic performance. And I've worked on many sites where people are absolutely terrified of making any changes whatsoever. Now, SQL plan management is meant to be the tool that will need, but it's not meant to be, it is the tool that means that will never be a problem again. We solve the major issues of change control. We can give you an absolute guarantee, if we configure this as part of your upgrade, that SQL statement execution will never regress. Well, what sort of problems, what sort of issues can cause SQL statement plans to regress, performance to degrade? New statistics. Well, after we upgrade your database, you're going to be getting new statistics every day, and they're calculated in a very different way, in some very different ways than the way they were previously. New statistics should be a good thing. They should give the optimizer the best possible chance of developing a good execution plan. Sometimes they are disastrous. Schema changes. Things like new indexes, materialized views. Again, should be good, can be bad. Parameter changes, all the tuning you do to fiddle around with parameters to improve performance, can be good, can be bad. Upgrade, of course, is the most obvious issue. Even platform migration. Any of these changes are meant to be for the better, but they can be seriously bad. I was just looking at one little example. I have to be very careful with showing you examples, by the way, because of reference sites, referenceability sites. I can't show you anything from current production customers. So this is the best example I have of new statistics causing a most extraordinary change in performance. This is a StatsPack report. This is going back a while. It's a fairly old StatsPack report from an e-business suite database. And some of you may even recognize this query, those of you who work with e-business suite. This query here selects vendor name, item description, vendor products, and so on and so forth. At the time I generated this report, we had 90 executions of that statement, and the total execution time, 1,015 seconds. So that's about, what, 12 seconds per execution, just on the edge of being acceptable, because it's a pretty horrible statement, but you're getting an answer in 12 seconds. I got a phone call one morning, basically saying, our whole database is completely broken. Why? Because this statement went from 12 seconds to 3 hours. And here was the proof of it. Let me just collect that identifying number. I generated another StatsPack report on the current version of the database to see what on earth was going on. And we found that that one statement had gone to there we go. One execution, and that's the same statement, select vendor and so on. The one execution took 8,845 seconds. And that was an overnight change. So one day, 12 seconds, next day, 8,800 seconds. No changes at all, or so the end user said. And that's the sort of issue we want to prevent. Now, why did that particular case happen? Just for completeness, that was new statistics. They'd analysed the database, and new statistics meant a new execution plan that was disastrous. And that is the sort of thing that we intend to prevent. So how do we do it? 11G new feature that I hope you'll let us implement for you called SQL Plan Management. So the idea then, we want to make sure that plan changes, if they work at all, will work as planned. So often You do everything on your testing and development systems, do it on live and it's different. We want to make sure the production really will not ever degrade. And of course unplanned changes like the one I just gave you, they've got to be stopped completely. The issue here is largely Oracle's dynamic parsing, and this is where the second topic we'd hoped to have time to do today, but Dave unfortunately isn't up to it. Believe me, I know, I've been talking to him. But Oracle's dynamic parsing does work against stability, and the adaptive cursor sharing feature, a very powerful new feature, can sometimes make the situation even worse. That because we parse statements possibly for every execution, but most likely every 2 or 3 days, and the nature of the application, a reparse can produce a dramatically different plan, dramatically different performance. The alternative is to force stability. If you force stability by using the old feature of stored outlines, then you totally freeze the system. You will never get any improvement at all. So what we want is a mechanism whereby changes are controlled in a fashion that means a change will be accepted if it's for the better, but rejected if it's for the worse. And that's done through what we see on this slide here, managed plan evolution. I'm going to go to a demonstration at this point to give you an idea of what we're trying to achieve. Those of you who were with us a couple of weeks ago will know that I like nothing more than falling flat on my face for trying to make demonstrations. So what we do is done through a couple of optimizer of parameter changes. Now, this is why I so like this facility. I, as DBA, can enable this declaratively. As database administrator, I can ensure that performance will never degrade without having to do anything to your software, not even having to work with your program. If you need do nothing at all. I can do it all declaratively. So, I'll just create a table. Table tab 1. Object. So I want a decent sized table. That's going to have about 70,000 rows. Now, our critical parameters that we enable to do this show parameters, 2 new parameters with 11G. These optimizer capture SQL plan baselines. Concept of a baseline. A baseline is a history of the plan execution. By default, this facility is disabled, so you'll get normal dynamic parsing and possibly quite dramatic changes from one day to another. I'll separate those parameters to true. System sets. Capture SQL plan baselines equals true. This instructs the database to capture copies of all execution plans that are ever used. This must be controlled. It can take up a considerable amount of space, but we would plan for that and arrange its space budget. But from now on, I'm going to capture all execution plans. Then the second parameter I'll change will be use them. Once I enable the use of the baselines, Oracle will now monitor execution plans, and if a new plan comes in, it will not be used. A plan will not be used until it has been proven to be better than the plan that was used previously. And that's the critical point. Changes are simply not permitted unless they're known to be better. If the change turns out to be worse, it will not be accepted at all. So, look at this table I've got here. Create table, select start more objects. There's no index on that table. There is no option whatsoever about how to run that statement. I'll just set the auto trace facility on. Trace. Explain so that we can see the execution plan we're going to get. But I know what plan I'm going to get, so I go to that table. There is only one option, and that will be for table scans. I'll select. I'm going to put a comment in here. Just put my initials in there so that I can identify the statement easily later. If I select maps object ID from, so I create table tab 1, tab 1. There's only one way to run that statement. Full table scan. So back come my 70,000. The highest object ID is 77,000. Full table scan, the only way to do it. Right, what do I have in my baselines? Well, the execution plan for that statement should indeed have been captured. I'll just set trace off. There's a view, DBA SQL plan baselines. And that will show you for each SQL statement identified by SQL text or by SQL handle. we see the plan has been saved under a certain name, and we see whether the plan has been accepted for use. Only plans that have been accepted will ever be used. So I'll take SQL text and the name of the plan, and whether it's been accepted from this view. And I'll put in the predicate. It is just the statement I want. SQL text like is my identifying string. So I'm having to move a couple of windows around. See what I am. SQL time baselines was on true. And that. Oh, I missed out a percentage symbol. That's what I missed out. Try. Right, there we go. There's my statement. And there's the SQL plan that's been saved, and it's been accepted for use. The first plan ever developed for a statement must be accepted, because you have to run the plan some time. If I make a change, I'm actually going to make a change that will, any change at all will do in principle. So I'll make a change and we'll see what happens when I rerun the statement. Does the change I make have any effect at all? Now, the change I'll make will be a fairly basic one. I'll just create an index from the previous way. If I create an index, IND1, on tab 1, objects, ID. So this is me as a developer trying to improve things. So I create an index on it. Well, that index really ought to help that statement. Select max ID from tab 1. Well, is it going to be used? Well, let us find out. I'll set auto trace on expire and rerun my statement. Now, there we are. Full table scan. So my statement is identical. I've created a new index. I am still using the old execution plan. Why? Because I've enabled SQL plan baselining. The baseline was used. So you can see the execution plan is absolutely frozen because at this precise moment, Oracle doesn't know if the new version, if the improvement is for the better or for the worse. Take a look at what's in the SQL base, the SQL management base. Disable that again. And see that we now have 2 copies. That's the execution plan that was first used and is still being used repeatedly. It does the full table scan. But there's another one there. And that is flagged as accepted no. So Oracle has realized, hey man, I've come up with a new plan. I ain't going to use it because I don't know if it's better or worse. Right. What do we do next? We have to test it. What we would do at this stage is create an automatic job that would test whether new plans are better or worse than old plans. How do we do that? We use a package, DBMS SPA. Oops, sorry, SPM, DBMS SPM, SQL Plan Management. And this package is how we administer this entire system. And in particular, we test whether new execution plans are better or worse. I'm going to do this interactively. Of course, for a real customer, we'd always set up jobs to do this automatically. We use the evolve SQL plan baseline procedures. It's overloaded. This is the simple one which I'll use. We evolve the plan, giving it 1 statement, or you can give it a set of statements, or we can automate the whole process. The evolve process tests new plans to see if they are better or worse than the plans that we used previously. So, the plan returns a long, so this procedure returns a long, so it's not to data returned. So I'm doing this interactively now, but of course in the real world we'd always do it through an automatic job. So select DBMS SPM dot the test procedure is to evolve SQL plan baseline.
Hi John, question in the queue please.
Okay.
This may come clear as part of your presentation, you may want to do it that way, but what metrics is used to determine if the statement plan is better?
Wall clock time. Wall clock time. It's nothing to do with, that is the most basic metric you've got. It doesn't go by things like I/O, it doesn't go by CPU usage. It goes by how much time from the moment the call was received by the server process to the moment the fetch back to the user process is completed. It's wall clock time, which is almost certainly what you would want. Okay.
Great.
So to test this one, but you'll see the metrics, the statistics it uses coming up in the result of this. That was a good question, actually. It's very timely. It fits perfectly with this. Now, to test a plan, we use the evolve SQL plan baseline procedure, and I'll test this new one here. This is the new plan that was developed after I created the index and has not been accepted for use. So we test it and see what we get out. Right, so that was the plan that was developed, and here's the report. Plan name. You can give it a time limit, of course, because normally you might find you've got thousands of different plans. If you do something as dramatic as creating an index or just a materialized view, there could be hundreds or thousands of statements where you get new plans. Well, the results are pretty dramatic here. Time used 0.327 seconds, 520 times better than the baseline plan. Therefore, the plan's been accepted for use. And you can see here
Excellent.
the elapsed time coming through.
I'm sorry, John, I thought you were pausing. I have another question in the queue when you're ready.
Take it now.
Does the SQL text have to match exactly to make use?
Yes, it does. It's an exact match because we're talking about reusing cursors. It needs to be a precise match. So if you're running ad hoc SQL, well, you're not going to get much benefit. Ad hoc SQL is almost certainly going to be dynamically parsed every time, so this would not apply. Now, this will be for your store procedures. And that's the sort of thing, like that example I gave you from those old StatStat reports. It's code in store procedures that this is really aimed at.
This next question, I think this next question will bump into our adaptive cursor sharing discussion in the next session. What if you have skewed data and you want different plans based on different bind variable values?
This is why I had hoped to talk about this at the same time as adaptive cursor sharing. The mechanisms work together, and I think probably next time we'll need to come back to that. In some circumstances they can work together, in some circumstances they can work against each other. To give a very short answer at this point, if you enable this mechanism that I'm describing here, adaptive cursor sharing, in effect is postponed until tomorrow. Because for the first day, you will get one plan and one plan only. The new plans will be developed due to adaptive cursor sharing, but not used. The alternative plans wouldn't be tested until probably you run an overnight job, the equivalent of what I've just done interactively. Then the next day, you would have a set of plans available which could be used adaptively. It's quite a complex topic the way they interact, but they do interact, and I'll ask you to trust me at this point. Okay. So back to this. You can see what the topics go together here. We've now proved, or Oracle has tested this and found that my index does indeed give a better plan. Note that this report here doesn't say why the plan is better. There's nothing about it's better because I use an index or materialized view, or the bind variables are different or whatever. All it knows is it checked out the statement, found an improvement. As a result of that, if we go back to the view that's showing what's going on, we now find that, hey, both plans are accepted. In the case of adaptive cursor sharing, you might find you have 20 accepted plans once they'd all been tested. And from now on, Oracle knows that there are two plans, both of which are available for use, and depending on the circumstances, it would choose which one was best. But it can only choose plans that have been proven to be superior. So the final check, what's happening now, let's set auto trace on, and see if it really does work. I'll rerun that same query, and hey, uses the index. Why? Because there's an accepted plan. And this is a really, really powerful technique. So coming back to my slide here, just by setting two parameters to capture plans and enable their use, no plan will ever be used if it hasn't been proven and accepted already to be better. So initially you get no changes. In effect, you freeze it. But freezing's no good, because that means you'll never get an improvement. Things won't get worse, but you won't get an improvement either. And that's where we have to evolve the plans. Now, I did it interactively, but what we'll normally work towards is a completely automatic process. So, we enable the parameters, all plans are captured and saved in sysOrt's table space in the workload repository. New plans, not used. Reverts the best previously accepted plan. The best in terms of bind variables and so on, what the circumstances happen to be. Then we configure typically a daily job. I won't go into the details of doing all that, but we have to configure automatic testing of new plans. The end result of that is that any statements that have deteriorated will not be accepted, will never be used. Improved plans then become available for use, but accepted doesn't mean they're going to be used. It becomes possible to use it. We still have dynamic parsing. The end results, changes are held back until they've been proven to be good, to be for the better. And the end result of all that is that we can absolutely guarantee that your performance will never degrade. With regard to upgrade, of particular importance, this is backwardly compatible with previous releases up to a point. It's possible to capture all your code on, say, release 10 database, then test it on release 11 database. And that way we can ensure, which is the point of this particular series of seminars, that upgrade will never cause problems. But generally speaking, it's equally powerful and possibly a lot more useful for day-to-day maintenance. Parameter changes, statistics changes, the whole process can be automated of guaranteeing things will only ever get better. And that's why I would strongly recommend that if we upgrade your databases, you let us do this. Back to you, Dave.